So this is called a phylogenetic tree, and it's going to map out the evolutionary relationships between different species and or lineages. And if you look closely here, you can see that leglessness or the evolutionary loss of limbs evolves independently at least twice in the reptilian clade. Once here in the true snakes, like this milk snake here, and then again in the lineage that is to become the glass lizards. You can see that the eastern glass lizard is going to share a common ancestor with the monitor lizards. So, in spite of looking morphologically a lot like snakes, morphologically means in respect to its form, its morphology, glass lizards are actually much more closely related to monitors. They share a much more recent common ancestor than when they share a common ancestor with snakes. The point here is that both of these lineages have converged on a similar ecological niche. Both glass lizards and snakes are hunting small prey, arthropods, amphibians, and rodents in the leaf litter on the forest floor. So, therefore, because their niche is very, very similar, natural selection has exerted similar selection pressures on these two genetically very distinct lineages, and over evolutionary time produced very similar morphologies. And it's not just the reptiles that have evolved leglessness. This is a caecilian. This is actually a legless, limbless amphibian. So this guy is much more closely related to salamanders and even frogs than it is to snakes or glass lizards. But again, natural selection has shaped this morphology over time in a completely different branch on the tree of life. So I know phylogeny is kind of a funky word, but when you hear the word phylogeny, it just implies the evolutionary histories of species or groups of species. It's thinking about who is more closely related to who. So these evolutionary relationships are most often illustrated using phylogenetic trees, very similar to what Darwin sketched out in his secret notebooks all those years ago.